Look, when the applied voltage is made negative, that means this electrode is connected to the negative terminal of the battery. The electrons that are emitted and which are trying to come near the electrode, they are being repelled. So, larger the negative voltage, look, if the voltage is made more and more negative, you can see the current goes on decreasing. Say, for small negative voltage, this much current. So, this much, so many electrons are now not able to reach. So, the current has decreased. If the voltage is made more negative, more electrons are stopped and the current has further reduced. For this particular voltage, even the most energetic electron has been stopped, and therefore we call this as the stopping potential. We call this as the stopping potential. Now, looking at Einstein's photoelectric equation, energy of the photon is equal to work function plus kinetic energy of the maximum energetic electron. Now here, if the applied voltage between them is this, and let us say the applied voltage is just equal to the stopping voltage V0, then in that case the energy, the kinetic energy, can be written as charge into potential difference. Now, basically charge into potential difference is the work done, and work done is equal to change in kinetic energy. The electron which is emitted from here has a kinetic energy, and by the time it reaches here, it is just stopped. It is just. So this is basically work energy theorem. Potential difference into charge is work. Potential difference into charge is work. Work done by the electric field to stop the most energetic electron is equal to change in kinetic energy of the maximum energetic electron. In fact, the kinetic energy has been reduced to 0. So the net change is equal to Ke max. So this equation now can be written as energy of the photon equal to work function plus E into V0. Now here, energy of the photon as represented by the equation h nu, E equal to h nu. So h nu equal to phi plus E times V0. Now, work function of a metal, if we have chosen a metal, that means the work function is fixed. If I say a metal has work function 1 electron volt, and now a photon of energy 2.5 electron volt is incident, then the energy of the maximum energetic electron would be 1.5 electron volt. Now, if it is 3 electron volt, then the energy of the maximum energetic electron would be 2 electron volt. If it is 3.5 electron volt, the energy of the maximum energetic electron would be 2.5 electron volt. So what we notice here is that if the energy of the photon, that is the frequency, is increasing, frequency of the incident light is increasing, a larger and larger stopping potential is needed. So this is what we notice in this graph, that if the energy of the photon is increased, that means if the frequency is increased, you may notice here, if the frequency of the incident light is increased, a larger stopping potential is needed, because frequency. Increasing the frequency means increasing the energy packet. Increasing the frequency, according to Einstein, means increasing the energy packet. And energy packet is h nu. If you are increasing it, that means the kinetic energy of the maximum energetic electron will also increase. And if the electron is emitted with a larger kinetic energy, to stop it, you need a higher stopping potential. So, stopping potential in a way is related directly to the frequency. And this relation can be better written as h nu equal to phi plus E into V naught, which means V naught equal to h by E times nu minus phi by E. Now, if you represent this on y-axis and frequency on x-axis, then this is the slope and this is the intercept. So it is a straight line graph. The graph between stopping potential and frequency is a straight line graph with a constant slope, and the intercept is the work function divided by E. So, work function of the metal decides the y-intercept. But look, slope is h by E. H is a universal constant, Planck's constant, and E is also a universal constant, the charge on electron. So, slope is a universal constant in this case. That means, if for metal this is the slope, so if the slope is theta, for any metal, any other metal, the slope would remain the same, though the intercept will change. Intercept will change because there is another metal now. Instead of metal A, we have metal B, and for metal B, the work function is different. So in this way, Einstein could explain photoelectric effect through and through.